we've just done. Okay, 7 leaf plots. Even if you think about that, we have those 7 leaf plots, and we had a bunch of numbers here. Something like that. Let's say we had a 7 leaf plot that looked like that. If you took this whole thing like so, group it. And you just rotate it like this. Okay? So if you could just turn the 7 leaf plot on its side, just rotate it. Well, what does it look like? It looks like a dot plot or a bar graph, right? And then if you look at the information, so one of those 7 leaf plots that we did in the assignment previously, if you looked at it, the middle number here had the highest amount, and the ones on the outside had the smallest amount. And you could have actually done something like this to get a normal distribution. So that's what we're talking about here. You can have stuff distributed. We talked about skewing when we did box and whisker plots. Okay, you can have stuff like this. They can be spread out more on the left. All right, more on the right, or it could be all jumbled up. So remember, if most of my data is here, which way is this skewed? Very good. It's skewed left. Don't fall into that trap of thinking it's skewed right. Skewed means away from the data. So it might be a good idea to circle and write this like we just did. Here, most of my data is on the left, lower scores, but some people did okay, so it's skewed right. Now, that third one, there is no skewing. It's just the data is all over the place. There's no pattern. There's nothing to see there. No, I mean, it's already here. So I was just wanting to talk about skewed left and right as a reminder, because it's a very often mistaken concept. You'll screw that up all the time. Okay, here's the bell curve. Okay, because it looks kind of like a bell. It's also called a normal distribution. Now, if you ever heard people talk about the old days, you might have heard of how about teachers who grade on the curve. All right? What that means is they're taking the data, no matter what the data looks like, and shoving it into the shape. So let's say, for example, I gave a test, and most people just bombed it. Okay? And, you know, well, actually, let's go the other way. Let's say I did really well, but I'm one of these teachers who grades on the curve. So you could actually get a 70, but if you were the lowest grade in the class, your 70 would not get you a C. Your 70 would be shoved down on the lower end and be an F. Because I'm going to make all my grades fit into the curve. So therefore, the lowest grade, even if it's a good grade, might be an F because you're the lower end of the class.
That doesn't sound too bad.
And if you had an A, let's say you had a 92, you could still end up with a B because someone got 99 and they got the upper spot, and now everybody got A's. Nobody really grades like that anymore, but it used to be a very standard practice of grading on the curve and shoving people into this shape here. Okay? But there is still good things to come from a bell curve. Theoretically, some things should be normally distributed. Okay? And really, if you think about it, we do have a problem with grade inflation. Okay? too many people expect to just get A's and B's just for being in class and smiling and taking notes. Theoretically, there's nothing wrong with the theory of the bell curve. The majority of people should be in the middle, average. A B should be above average, and an A should be excellent. You shouldn't get an A just because you showed up and did some homework. That's not what an A should be. An A should be excellent, above average work. Okay? So that's why there should be fewer A's and fewer F's. You should not have a lot of F's either. Okay? Now, the idea of shoving people with a good grade down into the bell curve, that's not right. But theoretically, what this says is grades should be evenly distributed. You should have the majority of your grades C's, fewer A's and B's, and fewer D's and F's. Now, like I said, you're not going to take someone with a 70 and tell them they have an F. That's a bad idea. But theoretically, this is what your grade should look like. Now, that doesn't go over very well because every parent wants their child to have an A, every kid wants an A, everybody demands an A just for being there. But theoretically, A's and B's should be smaller math. Intelligence. Okay? If you think about intelligence, it should be normally distributed amongst the population. So the bulk of people should be in the average range. You only have a few people out here on the extreme that are super, super, super geniuses. Okay? And then down here, there should be only a few people on the other extreme. Okay? But generally, it should be normally distributed. That's what we're talking about here. This is the general shape of the bell curve. Now, when you have a normal distribution, this middle line here is your mean, your average, your middle number, and your most often. The mean, median, and mode all occur as the same number. Half of your data is on this side, and half of your data is on that side. Normally distributed. Okay? That's the theory behind it. So, here are the same concepts on with different graphs. So this is a box and whisker plot that is symmetrical. We talked about this the day we did this. You could fold it over that line, and this dot would end up on this dot. This line would match up with that line. Okay? That is evenly distributed. The median is the middle of the line and the middle of the box. This one is skewed right. Why? Most of my data is on the left side, but there's some data up here pulling the data to the right. It's skewing it to the right. So here again is, bad test scores, but someone aced it. So they're bringing up the class average. Consequently, on the other side, most of my data is up here. Most people did well, but somebody bombed the test. What are they doing? It's pulling the average down. It's reducing the class average. Okay? The box is larger on the right because the median, we're talking about this part, the median is moved left. Here, the box is bigger on the left because the median is moved right. We've talked about this already, but here's another just example of it. Your normal curve, your positive skew, and your negative skew. Okay? So skewed right towards the positive side, skewed left towards the negative side. Again, the mean and median are the same. Here, the median is less than the mean, so you can also think about it this way. Median is less than the mean. And here, the median is greater than the mean. I don't know why we're running into and when you look at it, the median is greater than the mean. This is where pencils are really good on paper, actually writing stuff down. And in the same concept, okay, and this is the exact same concept, just with a histogram. But now we're going to actually label it. So this one here is symmetrical. If you drew a line right down the middle and folded it, everything would match up. This one, the bulk of my data is down here, but it's being pulled left. So that's skewed left. And here, the majority of my data is here, but it's being pulled that way, so that's skewed right. Someone did really well is pulling up the class average. Okay, now standard deviation, you gotta follow this page. We're not doing it. Okay, we're not doing standard deviation. Standard deviation by hand is not hard to do. It is just time consuming and tedious. Okay, when you get into Algebra 2, you're going to be able to learn how to use the graphing calculator to work with standard deviation, and it's just a waste of time. So we're not doing that. It will not be on the test. Okay, don't have to worry about it. Okay, now, we've talked about this before. You can have more than one mode. Okay? So, a bimodal distribution is a continuous probability distribution with two different modes. They appear as two distinct peaks. Okay? Now, they're not exactly the same number, but you basically have up here and up here two high points. That's bimodal. All right. Multimodal is where you just have a bunch of peaks, more than two. Technically, we could say trimodal and quadmodal, but once we get past bi, we just say multi. So when there's a bunch of modals, bunch of peaks, we call it multimodal. Uniform distribution is kind of boring. It's literally just a box. It's uniform because it's the same number straight across. Nothing's changing.
Question.
Okay, so bimodal data. Well, even though they're not exactly the same, there's your bimodal because it's got two distinct peaks. Multimodal, hard to say, has at least three peaks, so we're going to call it A. And this one, even though it's a little bit slightly higher there, it's not worth mentioning. So it's basically uniform. So it is basically a rectangle. Okay, now, comparing data. If you look at this, if you draw a line straight down the middle, both of those graphs are symmetrical. Both of them are normally distributed because the highest point, the mode, is also the median and the mean. Okay? And you could fold it over 50-50. So they're both normal. They're both symmetrical. Now, Class B is the lower curve, Class A is the higher curve. Which one has a higher mean? Be careful with this one. Which one has a higher mean? Huh? B? This one right here? Class A, this one right here? No. Neither. This right here is the mean, and the median, and the mode. They have this, the line goes through the same point on both of them. Okay? This up here tells you how many. Now, we didn't talk about it, but just so you understand what standard deviation means, the answer is B because it's wider. So, standard deviation is how much it deviates from the center. Okay? So since A is thinner, it has a smaller standard deviation. And like I said, we're not going to calculate standard deviation, but you need to understand the concept of it. Just think about it. Deviate means to go away from. So the standard deviation is how far it goes away from the center. So since B is wider, it's got a bigger standard deviation. Now, which one has a smaller range? That's A. It's thinner.
Ooh.
Okay, last page. So now we're looking at comparing data on two box and whisker plots. Which salesperson has the higher median? That's the middle line. So here's Angela's median, here's Carl's, so it's Carl. Which graph represents data skewed to the right?
What is Carl? I mean, Angela. It's neither. It's Angela.
It's Angela.
It's Angela.
See how this is, the median's down here a little bit? The box is bigger. Okay. Okay, so estimate the IQR for both of them. So IQR is from here to here. So this is where you might have different answers. So for Angela, you might say 19 to 41. So you might say 19 to 42. If you said 18 to 42, I would accept that. There's some leeway here when you're looking at this. Now for Carl, right there, you might say 15 to 45, 15 to 46, 16 to 46, whatever. I would accept plus or minus kind of in that leeway there, because you're just drawing a line kind of estimating. That's why it says estimate the IQR. Okay, again, we have two box and whisker plots. You can see the general brand is higher overall for Q1 through Q3. The regular brand is lower. Okay, which brand has a more narrow IQR? In other words, a smaller box. So this means a smaller box. And that's going to be natural. Which brand has a higher quality rating? That's overall. You can see the whole thing, almost the whole middle part here is to the right of the entire box of the other one. So natural. What are the ranges for both brands? Now remember, range goes from here to here. So for regular, we would say maybe 11 to 85. And for natural, we're looking at maybe 33 to 89, approximately. Again, if you said 34 to 88, well, you can say to 90 because it's not to 90. But if you said 88 or 89, that's fine. Now, the third quartile, remember, that's this line and this line. How the third quartile of the regular brand compares to the lower quartile of the natural brand. So, my bad. So, for this one, listen please. They're comparing the third quartile of the regular brand with the lower quartile, Q1, of the natural brand. Okay? Almost the same. maybe 53 to 55. You know, somewhere in there, 53 to 54. They're pretty close. They're almost equal. So the natural brand is head and shoulders above the regular brand.